Good evening everyone, my name is Abdul Saud Khan, roll number 23, branch mechanical second year, and today my topic is problems based on shear force and bending moment diagram. Good evening, my name is Abdul Saud Khan, roll number 23, branch mechanical second year, and today my topic is problems based on shear force and bending moment. So first we will go from easy problems to hard problem. So the first problem is, and these problems are based on simply supported beam. This is a simply supported beam means nothing but a beam with two forces acting on it and some forces acting on the beam. Suppose one force, second, okay, so these are the forces acting on a simple supported beam, and we don't know these two upward forces, we only know these downward forces, so we have to find these upward forces first. So let us name these forces A, okay, we have named it. Now we have to leave this much area for the shear force and bending moment diagram. So now we have to go as upward force is equals to downward force formula. This upward force RA plus RF is equals to downward force are 3 kN, 2 kN, 7 and 4. So upward force plus downward force is equal to, we got this. Now we have to take it as equation 1. Now we have to find the moment of the beam in clockwise and anti-clockwise direction. Clockwise means positive, anti-clockwise means negative. So the moment is taken out like this: 3 force into area. Moment is equal to, the formula of moment is force into perpendicular distance or area. This is the force, 3 into T, 3 into 2 in clockwise, so it is positive. 2 into 3, 2 into 5, 3 plus 2, then 7 into 3 plus 3 plus 2, then 4 into likewise. We have to find the moment, minus RF into 11. Then we will get RF. We have to make RF as subject. We get 10 point minus 10.18. Then substitute this RA in equation 1, RF in equation 1. Okay, so after that we got both the reactions RA and RF. By substituting RF in this equation, we got RA also. So now let's put the reaction on the diagram. RA is 5.82 and RF is minus 10.18. So after getting reactions, we have all the forces on the beam right here. So now we have to find the shear force and bending moment, which is the main part here. So shear force diagram. So we always have to start from this side if we have to find the shear force. So we have to first find shear force at F. In shear force, upward is taken as negative and downward is taken as positive. Shear force at F. What is the shear force at F? Minus 10.18. Now after F, what we have E. So shear force at E is minus 10.18 plus 4 to minus 6.18. Shear force is nothing but addition or subtraction of these forces. Minus 10.18 plus 4, then at D it will be minus 10.18 plus 4 plus 7. Likewise at C also. At A, shear force is 0 because as we know that upward force is equals to downward force. Likewise, we come from finding shear force from F till A. If we add everything, we get 0. So at A, shear force is 0. Now we have to solve this by adding and subtracting. We get the answers. At D is so now we have found the shear force. Now we have to find the bending moment diagram. In bending moment diagram, upward is taken as positive, downward is taken as negative. So bending moment at F is equals to 0. But at shear force, we simply have to add or subtract the forces on the beam. In bending moment, we have a formula, force into area. So at F, we have no force. We have to see it from right side. So the bending moment can be found by using this formula, force into area or perpendicular distance, and the bending moment we should find bending moment from the right side always, because a bending moment means force is minus 10.18 and there is no area. We have to always look at the right side. Like suppose if we are at E, the force is 4 and the distance is 1, and if we are at D, the force is 7 and the distance is 2 plus 1 3, and if we are at this what we call C, 2 into 3 into 2 into 1, then 7 into 3, then 4 into 1. Likewise we have to find the bending moment. So I have already done the bending moment here. Bending moment at E is 10.18 into 1, which is the same, then D 10.18 into 3, and then minus 4 into 2 at D, because C at D we have D 7 into 2 plus 1 3, then 4 into 1. That's how we have to find the bending moment. And after getting all the bending moments, we have to put it in the diagram here. First we have to put these lines like this from points like A, B, C, D, E, F. I have put lines like this. Then we have to draw shear force diagram first. Put a straight line. This upward is known as positive, the downward is known as negative. The upper part of the line is positive, downward line is negative. So the shear force at F, as we know, is minus 10.18. Minus 10.18. This bending or shear force diagram is not usually precisely accurate, so we can draw however we want. First, suppose the first number is minus 10.18, so I said that downward is known as negative. We have to take the line this much, how much we want, F minus 10.18. Then we have to take it towards E line. Now what's the second point at shear force at E is minus 6.18. Minus 6.18 means a little closer to the line. Minus 6.18, and at D it is 0.82. 0.82. 0.82 is a positive number, so it will come above the line. 0.82. Shear force at C is 2.82, which should be greater than 0.82. And shear force at B is 5.8. And shear force at A is 0, so it should touch the line like this. This is the shear force diagram. Now bending moment diagram. In shear force diagram you have to use straight lines like this, and in the bending moment diagram you have to use inclined lines, which I'll show you. First we have to put a straight line. Upward side is known as positive, downward side is known as negative. So the first value of bending moment diagram is 0 and second is 10.18. So first one is 0, here only 0, and second value is 10.18 at E. So see, this is the line, this is how we should take it, and bending moment 10.18. Upper side is known as positive. and at D. The value at D is the value at D is D is 22.54. D is 22.54 and the value at C is 20.08, which should be a little less than 22.54, and the value at B is 11.62. So the line is gradually decreasing, and at point A it becomes 0, and there is no negative number. That's why the line hasn't gone on this side. Positive. So this is how you should usually do the shear force and bending moment diagram problems, and it is very important according to exam point of view. So that's all. Thank you.